Okay, so topic for this video is going to be area. And our essential question here is going to be to figure out how on earth we calculate area for all the different 2D figures. So step one here going to be finding the area of a triangle. If you don't remember that formula, it is 1/2 BH, 1/2 base times height. The base and the height of your triangle should always form a right angle, right? It might not always be a right triangle like our little picture is right here, but your base and your height should always form a right angle. Remember, your height you could also think of as the altitude of the triangle. So let's give it a shot here. Find the area of some triangles here. Our first one, if we want to do 1/2 base times height, we got to find the base and the height. And I'm thinking that our base here should be this 20, and the height should be the 6, because that's where our right angle is. So we're going to do 1/2 times 20 times 6, which should give us 60 centimeters squared. Remember, area is in square units. For our second one, if we want to do 1/2 base times height, I would think that our base would be this side, which we actually don't know right now. And our height is the 9, because that's where the right angle is. The 15 is not really relevant for us right now, because it's not the base or the height. So we got to actually figure out what this is. Conveniently, in a previous video, we've talked about the Pythagorean theorem. So let's do that real fast. That would be x squared plus 9 squared equals 15 squared. X squared plus 81 equals 225. If I subtract that, I'm going to get x squared equals 144. So x is 12. Which means now we can get back to the main event. Let's do 1/2 times 12 times 9. And we will get 54 inches squared. Cool. That was a Pythagorean triple there, if you happen to spot that. It's the old 3, 4, 5 right triangle, but all multiplied by 3. Okay, so that's triangles, 1/2 base times height. No problemo there. Let's talk about some circles now. Circle formula, pretty famous one, pi r squared, where r is the radius. Let's give that a shot. So first one, let's do a little pi r squared. That's going to be pi times 6 squared. Pi times 6 squared. I'm getting 113.1 centimeters squared. For our next one, it is a circle, so we shall do 1/2, not 1/2, I'm crazy, it's just pi r squared. Pi r squared, I was thinking about the 1/2 already, because I saw they gave us the diameter and not the radius. They give you the diameter, the distance all the way across. Make sure that you only use the radius here. That's one way that they can get tricky with circles here. So we're going to do pi times 4 squared, which gives me, let's see here, I'm getting 50.3 centimeters squared. All right, moving right along, parallelograms. So this formula, this parallelogram formula, can be used for all types of parallelograms. So it could be used for a rhombus, it could be used for a rectangle, it could be used for a square. Remember, all of those are special parallelograms, so all of them can use the same formula of just BH. Sometimes it's a little easier, like for a square, when all 4 sides are the same. But all of them are just the base times the height. And remember, base and height always needs to form a right angle. Do not be deceived. You got to have a right angle for the base and the height. All right, so first one here, looks like a normal parallelogram. We're going to do BH. We're going to make sure we grab the base and the height, which form that right angle. We're not going to use that 10. We're not going to fall for that trick. We are going to do, oops, not in highlighter. We're just going to do 12 times 8, which is going to give us 96 centimeters squared. And then for our square looking guy over here, we're going to do base times height. Our right angles over here, really we would know that all of them are right angles, but remember also those tick marks mean that all the sides are 4. So we're just going to do 4 times 4. And we're going to get 16 feet squared. All right, hopefully no difficulties so far. Let's keep it moving. Let's get into some of the newer formulas here. Now, there's a special formula that can be used for a rhombus or a kite. And that one is going to be 1/2 D1 D2. So when we talk about D1 and D2, we're talking about the 2 lengths of the diagonals. And this can be used for either rhombus or kite. So if I'm looking at this first one, this one looks like a rhombus over here because we can see that all 4 sides are marked as being the same. So if we try this out, 1/2 D1 D2, we know that D1 is one of the diagonals, D2's the other one. Now, one other thing that we know about a rhombus is that those diagonals are bisected. So we do have a 16 and a 16 going that way. We do have a 24 and a 24 going this way. So I'm going to do 1/2 times 32 times 48. Actually, let me switch those around because that's how I highlighted it. That might look a little confusing. So the yellow diagonal for mine was 48. The green diagonal was 32. So if I do that, what am I going to get here? I'm looking at 768 centimeters squared. For my other one over here, 1/2 D1 D2. Let's say D1's going this way, D2's going this way. Now with the kite, the diagonals do not bisect each other. There is one diagonal that gets bisected. So this side would be 4, but the other one is not bisected, and we can see that by the 3 and the 10. So for this one, we want to do 1/2 times D1, which would be 13, the 3 and the 10, and then D2 would be 8 from the 4 and the 4. And when I do that, I should get 52, I believe. Yep, 52. 52 centimeters squared. Cool, cool. Now for those ones, do remember, it didn't come up in either of these, that in both of those, the diagonals are perpendicular. So there might be a case where you got to do Pythagorean theorem on a question like that to find out one of those missing pieces of the diagonal. But our next shape is going to be the trapezoid. Trapezoid's got a cool formula. It is 1/2 parentheses B1 plus B2 times H. So what do all those mean? B1 and B2 are our 2 bases. So remember the trapezoids have 2 bases, and the H should be the height. Okay, so you got your B1, your B2, and your H. All right, let's try those out. So for this one, let's see what we got. B1, I'll take the 10. B2, I'll take the 8. And the H will be the 4. Do not be distracted by the 5. It is not relevant for our area formulas. So this will be 10 plus 8 times 4. And if we do that, I should get 36 centimeters squared. For our next one, same formula. I'll take the 6 for my B1, the 8 for my B2, and my height will be the 3. Once again, do not be distracted by the 4. It is not relevant. So this will be 6 plus 8 times 3. And that should give me 21 centimeters squared. Okay, so that might have been a new formula. Maybe the kite one was, but I think you've seen those previous ones before. Our last bit is definitely going to be some new stuff. This is going to be the formula for a regular polygon. Now, first of all, remember two things about a regular polygon. A regular polygon is an equiangular and equilateral polygon. And its formula is pretty wild here. It's 1/2 lowercase a capital P. So what do these things mean? Lowercase a is known as the apothem. Okay, that's the apothem. The apothem is the distance from the center of the polygon to the midpoint of one of the sides such that it is perpendicular. Okay, so the apothem makes a right angle at the midpoint of one of the sides. Now, the P is the perimeter of the whole thing. Now, remember that the perimeter is consisting of congruent sides. All the sides are the same going around the entire thing. Remember, since this is a regular polygon. So you do 1/2 times the apothem times the perimeter. That's going to be our formula. Now, what's going to help us figure these out is by recognizing how to find this little angle. Okay, this angle is formed by the apothem and the radius of our regular polygons. The radius is the distance from the center to one of the vertices, one of the corners of our regular polygon. And to find that angle, because that angle is going to be super helpful, to find that angle, we are going to do 360 divided by 2n, where n is the number of sides. We've seen n before in some polygon formulas at the beginning of this kind of unit. So 360 divided by 2n is going to be how we find that angle. Okay. Let's just dive in. You're going to see how helpful that formula is. So example 6 says find the area of the given regular polygon. We can see that this is a regular triangle. So if we were to set up that formula right away, 1/2 AP, well, we certainly don't know the apothem, do we? The apothem's blank. We could find the perimeter. There's 3 sides. Each side's 4. That would be helpful. But generally, what we're going to do here is start off by doing the 360 divided by 2n. This would be 360 divided by 2 times 3. Since our n is 3, there's 3 sides. That would be 360 divided by 6, and we would get 60. So what does that mean? That means that if I draw in the radius, this little angle right there is 60 degrees. Okay? And that's going to be really helpful because now we've got ourselves a little 30, 60, 90 triangle. Right? This little triangle right in here is now a 30, 60, 90 triangle. And that's going to be very beneficial because we know that the apothem also splits the bottom side in half, right? So if the whole base of the triangle is 4, then we know that each side is 2 and 2. So how does that help us? Well, like we mentioned, the perimeter we could have already found. This is just 3 times 4. Our perimeter is 12, right? So if we wanted to do 1/2 AP, we don't know what the apothem is, but we do know that the perimeter is 12. So really what we're missing right now is just the apothem. If we could figure out the apothem, we could plug it into the formula. Now the apothem, this little a right there, is the short leg of our 30, 60, 90 triangle. And if you remember how to find the short leg, the A, is always equal to the long leg divided by root 3. That was our 30, 60, 90 rule. Now, we don't like having the root 3 on the bottom, so we multiply by root 3 over root 3, and we're going to get 2 root 3 over 3. That is the apothem. 2 root 3 over 3. Now, that's pretty ugly, I know. But when we multiply all this together, some cool things are going to happen here. So if I just leave the root 3 alone for a second, and I just multiply 1/2 times 2/3 times 12. If you're typing this into your calculator, just don't type in the root 3. We're just going to have the root 3 kind of hang out, go along for the ride. 1/2 times 2/3 times 12 is 4. And then we still have the root 3. So this would be 4 root 3 centimeters squared. So by figuring out that that was a little 30, 60, 90 triangle by doing the angle formula that we had, we could figure out the apothem, and then we could find the area. All right, let's try another one here for this regular quadrilateral. Now, for quadrilateral, our n is 4, so I'll do 360 divided by 2 times 4, and I'll get 45. So that means that we've got ourselves a little 45, 45, 90 triangle being formed by the radius and the apothem. So let's see where we stand right now. 1/2 AP. Do we know the apothem? Do we know the perimeter? No. In fact, all we know is the radius of this thing. But the radius, the 6th, is the hypotenuse of that 45, 45, 90 triangle. So if I want to find the apothem, which is one of the legs of it, I would remember that the leg, which is the apothem, is equal to the hypotenuse divided by root 2, right? That was our 45, 45, 90 rule. Now we don't like having a root 2 on the bottom, so we do this. That would be 6 root 2 over 2, which would be just 3 root 2. So my apothem is 3 root 2. So that's 1/2 times 3 root 2 times the perimeter, which I don't know what the perimeter is right now, do I? But here's the deal. Remember, both legs of the 45, 45, 90 triangle are the same. So this little part is 3 root 2. Which means that this little part is 3 root 2, which means that an entire side of my square is 6 root 2. So I can find my perimeter by doing 4 times 6 root 2, and that would be 24 root 2. So now we've got everything we need. So where were we? We know what the perimeter is. We know what the apothem is. Time to multiply some stuff together. So I'm going to leave the root 2's out of it right now. I'm just going to do 1/2 times 3 times 24, which gives me 36. Sorry, let me get rid of that 1/2. So I just multiplied the 1/2, the 3, and the 24, and I got 36. Now the root 2 times the root 2 would be root 4. But what's root 4? Root 4 is 2, isn't it? So 36 times 2 is 72 centimeters squared. Very cool. All right. What do we have here? We got a hexagon. Okay, so same deal. We're going to start off by drawing in the radius and figuring out what this little angle is up there. So hexagons have 6 sides, so I'm going to do 360 divided by 2 times 6. That'd be 360 divided by 12. That is 30. Okay. So let's set up our 1/2 AP and figure out where we stand. So the apothem is this guy. We certainly don't have that. The perimeter, oh, this one's nice because we do know what the perimeter is, or we can at least find it really fast. The perimeter would just be 6 times 12, which is 72. So we know 1/2 times whatever the apothem is times 72 will be what we end up doing here. Now, if one of the sides is 12, that means that both of the little parts at the bottom where the apothem intersects the side would be 6. So if I want the apothem, then I need to recognize that this little triangle right there is another 30, 60, 90 triangle. And the short leg is 6. And if I know the short leg, then I can find the apothem, the long leg, by doing 6 times root 3, which would just be 6 root 3. So the apothem is 6 root 3. So let's do 1/2 times 6 root 3 times 72. Remember, just leave the root 3 out of it. I'm just going to do 1/2 times 6 times 72. And I'm going to get 216 root 3 centimeters squared. And our last a pentagon. So 360 divided by 2 times 5 is 36. That's what this angle is up here. Now this one's a little bit different because we don't have a special right triangle with a 36-degree angle there, do we? So this one, we're going to have to do a little bit of work on this thing. Let's see where we stand as far as our given information. We know we need to do 1/2 AP. Do we know the apothem? No, we do not. Do we know the perimeter? No, but we can really easily find it on this one. There's 5 sides. Each side's 10. So our perimeter is 50. So in the grand scheme of things, we got to just find the apothem, and then we can plug it into our formula, and we can get the area. Now, if each side is 10, that means the bottom of our little triangle there is 5. Now, we want to know the apothem. And conveniently, from the perspective of the 36-degree angle, the 5 is the opposite side. The radius is the hypotenuse, and the apothem is the adjacent side. So if we want the adjacent side, and I know the opposite side, I've got a friend called tangent that can do this. I've got to use a little trigonometry. This would be tangent of 36. Tangent is O over A. So that's 5 over the apothem, 5 over a. I'm going to put this side over 1 and cross multiply. I'm going to get that 5 is equal to a times tangent of 36. And then I will divide by tangent of 36. And I should get what a is. 5 divided by tangent of 36. Remember, whenever you're doing this, make sure you are in degree mode. I'm going to get 6.9 for a. Okay, and then we got all of our information. So let's just do 1/2 times 6.9. Half times 6.9 times 50. And I'm getting 172.5, and this would be centimeters squared. So the first 3 regular polygons that we did, the triangle, the quadrilateral, and the hexagon, those are the ones where you will get a special right triangle being formed on the inside. Those are the ones that you should be using your special right triangle rules to help solve. So those are the ones that might have radicals in their answers. If it is anything other than one of these 3, so if it's a pentagon or a heptagon or an octagon or a decagon, you're going to have to use trig on those. You're going to have to use trigonometry to solve those ones. But if it's one of these, then you should be able to do some special right triangles in there. All right, so you've got some examples to try out. There are 2 regular polygons at the bottom. They are both ones that you should use special right triangles on, so you won't have to use trig. But all of these are ones that you should just be able to use some of the basic formulas from earlier on. Give those a shot and come back and finish this video when you're ready to check. All right, first one, we should have been doing pi r squared. This was pi times 7 squared. And you should have gotten 153.9 centimeters squared. Second one, triangle 1/2 base times height. Should have been 1/2 times 30 times 8. And that should be 120 centimeters squared. Then we had a trapezoid. 1/2 b1 plus b2 times h. That should be 1/2 times 16 plus 14 times 5. And that should be 75 probably. Yeah, 75. 75 centimeters squared. For our rhombus looking guy over here, we're going to do 1/2 d1 d2. That's 1/2 times 12 times 6, which should be 36 centimeters squared. Then we got ourselves a little hexagon here. Our little right triangle, you should have found out that that top angle was 30 by doing 360 divided by 2 times 6. Then we find out that the little bottom parts are 5. That does mean that the apothem, 1/2 AP here, does end up being 5√3 because that's the long leg. Your perimeter should have been 6 times 10, which was 60. So that should have been 150√3 centimeters squared. For the triangle here, if you did 360 divided by 2 times 3, you got 60. So the top part was 60 there. So if we're doing 1/2 AP here, let's see here. What do we know? Oh, we actually know the apothem. We know the apothem is 4. So we got to find the perimeter here. Now, if this is a little 30, 60, 90 triangle, the long leg, if the short leg is 4, because the apothem's the short leg on this one, the long leg's 4 root 3, which means the other side's 4 root 3, which means that an entire side of the triangle is 8 root 3. So the perimeter should have been 3 times 8 root 3, which is 24 root 3. So 1/2 times 4 times 24 root 3 should have given you 48 root 3 centimeters squared. All right, hopefully that went well for y'all, and that's going to wrap up our video.